So friends, here is the next question, and this is the question related to statistics hypothesis testing. And you may expect either this question or some variant of this question being asked, right? So the question is very simple. A coin was flipped 1,000 times and 550 times it showed head. So I tossed a coin 1,000 times. 550 times it landed on head. Do you think the coin is biased towards head or not, is the question. How can you solve this type of problems? Now friends, one thing is to know that whenever such question comes, that do you think that this is biased or that thing, you can always solve that with the hypothesis testing. Okay, so what will be my null hypothesis in this particular case? My null hypothesis will H0 will be that the coin is unbiased. Okay, the status quo, that my coin is unbiased. And now we have to assume some significance level alpha or confidence interval, that is like in other way of saying the same thing, right? Now what is coin toss? Coin toss is a Bernoulli event. It is there are only two outcomes, right? Whenever there are only two outcomes, we call it Bernoulli events, right? And Bernoulli event can always be modeled by binomial distribution. Why it is binomial distribution? There are only two outcomes. There are not continuous variables, right? There is a head or tail, two outcomes. So we can do binomial distributions of 1,000 coins. What will be my null hypothesis? My null hypothesis will be that what should be the number of cases. The null hypothesis is that the coin is unbiased. But how many heads I should expect under null hypothesis if the coin is totally unbiased? Equal probability of head and tail. That means I should get 500 head, correct? And what is the standard deviation? The standard deviation of a binomial distribution is n into p into 1 minus p, right? Square root of that. This is the standard deviation. So what will be the standard deviation? Is 15.81. So let's write it down. Okay, let's write it down. So what is my H0 or null hypothesis? That the coin, erase it, that the coin is not biased, right? What will be my alternate hypothesis? That the coin is not biased. That means coin is biased, right? This is the way I write my alternate hypothesis. Okay, now what should be my expectation of heads? Okay, my expectation of head if the coin is fair in case of H0 is 500, correct? How many actually I got? Actually I got 550, and the question is being asked that whether my coin is biased or not biased, right? Do you think that the coin is biased, right? In that particular case, I'll try to reject my null hypothesis. Okay, so to prove that my coin is biased. Okay, now what was the how much was the your standard deviation? Was 15.81, right? My standard deviation was 15.81, right? Now how will I calculate my hypothesis, right? So when we can calculate the probability of observing 550 or more heads in 1000 flips, assuming the null hypothesis is true. So what will be my z value? My z value will be nothing but 550, sorry, I'm writing here, 550 minus 500 divided by 15.81, my standard deviation. And what that value will come? That value is 3.16. That value is 3.16. This is my standard deviation, right? Or this is my z-score, sorry, z-statistic. Okay, now how can I do hypothesis testing? We assume a normal distribution, right? And we call it that, what was our confidence interval or alpha? Alpha was given as 0.05, right? 0.05. What does it mean? That means 5%. What will be the confidence interval? That 100 minus 5, which is 95%. With 95% confidence level, or alpha being 0.05, I have to say that whether this z value would have come by chance from it or not, right? If I have received, what is the question? The question is that I have received 550 heads. Can it happen by chance, or is the coin unbiased, right? Then what should I do? Again, over here, this is a two-tail test. Then this particular region should be, this is 0.025, so 0.025. This is the area, rejection area. On this side also the rejection area will be 0.025, right? What I need to calculate is nothing. I think I have an Excel sheet over here. Okay, let's see. I think this is better. So what was my alpha? My alpha is 0.05, right? My sigma alpha by 2, since I am doing a two-tail test, divided by 2. So on the right side, this should be the rejection ratio. Similarly, on the left side, 0.025 area is the rejection area. Area on the right to reject the hypothesis, 0.025, right? This green area, let's assume that this is 0.025. This whole area under the curve will be what? 1. Area on the left. So what is this region? The area on the left. If I remove 0.025 and the whole area is 1, so it will become 1 minus 0.097, 0.025, sorry, 0.975. So this white area is 0.975. Now what should be, if the area is 0.975, what should be my z-score for that? What will be my z-score? My z-score, if you have to calculate, you can use this Excel formula, norm S in, okay? So let's see, normal distribution, okay? The inverse of that, right? I'm calculating, okay? And what I'm giving, my B4 is 0.97. I'm giving the area over here, right? And if I'm calculating what is the z value, it is coming 1.95. That means to get the area 0.975 on the white side, the z, or the standard deviation which is away from the mean, is 1.95. And what was the z which I got from the hypothesis? 3.16. Where is 3.16? This whole rejection area starts from 1.95, right? My z is lying further deep into the rejection area, right? Further deep into the rejection area, correct? 3.16 will be further down. 1.9 will be, if 1.95 is here, where will be 3.16? Further right? If it is further right, then that means it is falling under the rejection area. If it is falling under the rejection area, then we can easily reject the null hypothesis, correct? If we are rejecting the null hypothesis, what does it mean? It means that what we are doing is there are 1,000 flips, right? If we are doing, then this coin is biased, right? That's what it is meaning, correct? Since we are rejecting the null hypothesis, okay, that means that the coin is biased. But one thing we should note is also over here that it is just the one sample. Typically it may happen by chance that we have landed in that particular sample there where we have gotten 550 heads, correct? So probably we should repeat this test multiple times and see whether the coin is really biased or not. But if the question asks you with one sample, 1,000 tosses, 550 heads, whether the coin is biased or not, based on this hypothesis testing, our answer should be, since our z is lying far towards the rejection region, right? And the standard deviation is standard deviation with this, with the 5% alpha or 95% confidence or 0.05 alpha, okay, is only 1.95, and my z is lying on the rejection area. I should reject the null hypothesis, and I have evidence to say that this coin is biased, it's likely biased, okay? So friends, I hope you got the answer for this. With this being said, I will pause the video over here. I will see you all in the next video. Thank you. Bye.